bring this charge at some distance. So then I'll have to apply external force, and then that would be the negative of this QE, right? Negative of this electric force. So this would be the force that we will be talking about in here, right? So this force will define that what is the work that we are doing. So this is the idea. Now let us get back to this work done. So the work done is right. So the work done, and I will write that we are bringing something from initial to final point, and we are bringing the charges, right? So what is that? So this is simply F external and dot dr from initial point to final point. This would be the work done, right? Is it clear? Is it clear, guys? So this is how we define the work done, right? Now, what I'm doing is that we know that this F external is negative of this electric force, right? So in the place of this thing, I can write this thing as initial to final minus Q and E dot dr. So this is the work done from initial point to final point. So this is the important formula that we have to remember. Work done is simply E dot dr from initial point to final point. So let's say if we are bringing some charge from A to B, so this would be simply A to B and E dot dr. Right. So the work done is dependent upon what? What can you guys tell me? The work done is dependent upon what? Yes. Any guesses, guys? What would be this work done? So the work done can be of different types, and this work done is dependent upon this electric field, right? So we can have two kinds of electric field. One would be that electric field is uniform. The other would be that the electric field is variable. Right? So if the electric field is uniform, what would be the form of electric field? This would be something like 3I plus 4J plus 5K. Something like that. So this is uniform electric field. What is variable electric field? This would be, let's say, 3x square I hat plus 4x square yj hat plus 3x cube k hat. Right. So this would be the variable electric field. This texting. Okay. So this is the variable electric field, and depending upon these two scenarios, you will have the work done, right? So let's say we have the for uniform electric field. So for uniform electric field, what would be the work? So this would be initial to final. This is minus Q and E dot dr, and this is initial to final. So for this uniform, this thing, we can take it outside, and this would be simply minus QE dot R final minus R initial. So this would be the work done. And this we have to remember. For uniform electric field, this is the work. Is it clear, guys? Is it clear? Where RF and RI
Yes,
are,
sir.
yeah, so RF and RI are the position vector of these two charges. So wherever we are taking this charge. So we have this uniform electric field, right? And this electric field, we are bringing this charge from here to this point. So we are bringing this charge. So that would be the work, right? So now let us do some question based on this. And yeah, but let us first understand that what would be for variable electric field. So for variable electric field, this would be simply initial to final minus Q and initial to final V dot D. So these are the two things that we have to remember. Okay, and they would give you some values of E. So that is the idea. So now let us apply these things and let us do some questions. So we have some questions in here. And what is that? So let's do these questions. Okay, so this is the question, right? And we also know what is the electric field due to variable charge, what is the electric field due to the uniform charge. So uniform electric field. So what kind of electric field is this one? What kind of electric field is this one? Can you guys tell me? Yes. What kind of electric field is this? So electric field is this much. This is the electric field. 3 into 10 to the power 3 I have. What kind of electric field is this? Is it uniform? Is it variable? What kind of electric field is this, guys? So we don't have any variable X, Y, Z. So this is a uniform electric field. Right? This is a uniform electric field. So work done would be simply minus Q and there would not be an integral, right? So this would be simply E. So this would be simply E and dot R final minus R initial. So this would be the work done, right? And we are bringing from P to Q. So initial is P and then this Q. So this would be Q E dot and R final is RQ minus R initial is R. So this would be the work, right? We have all the values and then we can calculate the work. Now, can you guys tell me what is RQ? What is RQ? Yes, guys, what is RQ? So this is the coordinate of Q point. So RQ would be 3I plus 2J plus 5K. Similarly, RP. This would be I hat plus 2J hat plus 3K hat. So this is RP and RQ. Q value is how much? Q is 1 microcoulomb. So this is 1 into 10 to the power minus 6 coulomb. So these are the things, these are the values. Electric field we already have. So let's put all these values and find out PQ. So you guys please calculate and tell me what you guys are getting. Please calculate this thing and you guys tell me what you guys are getting. So Iram and Alia, every value you have, and please calculate this thing and tell me how much you guys are getting. So please calculate these things. Every value I have discussed, right? I have told you all the values. Put all the values in this formula and find out what is work done in moving a charge from P to Q. Yes, guys, please calculate this thing and tell me what is the answer that you guys are getting. Yes, Idam and Alia, whenever you guys get any answer, please tell me. And where is Nabil? Yes, did you guys get any answer? Okay, so let us do this thing. Right, and then you guys correct me if I am doing this correct or not. So you have charge that is 10 to the power minus 6, right? And then you have electric field which is 3 into 10 to the power 3 I hat, and then you have to take this with the dot product of the other vector which is RQ. RQ is 3I plus 2J plus 5K minus of this RP. RP is I plus 2J plus 3K. So then this is how much? This is 3 and 10 to the power 3 and 10 to the power minus 6. So this is 10 to the power minus 3. I dot, and what is this vector? So 3I minus I, that is 2I. And then you have 2J minus 2J, so that is 0. And then 5K minus 3K, so that is 2K. So that is the answer, right? And then this is how much? This is 3 into 10 to the power minus 3, I dot 2I. So that would be 2, right? And I dot K, that is 0. So only I dot I will survive, that this would be 2. So this is minus 6 into 10 to the power minus 3. And this is joules. So we can write it as minus 6 millijoules. So that would be the answer. Is it clear, guys? If it is clear, you guys just quickly note this thing down and then we'll do the next question. Please quickly note this thing down. Yes, whenever you guys have completed, please tell. Yes, whenever you guys have noted it down, and if you guys have any conclusion, please tell me. Yes, noted, guys.
Yes, sir.
Done. Okay, so there is a similar question like this only. And this is also, so you have this charge, you have this electric field, again uniform electric field, and this is P2Q. So this I will skip. Now we will do a question which is non-uniform electric field. So where is that? Okay, so non-uniform electric field, that would be, uh, okay, so this one is a little bit difficult one, but okay, this is not, yeah, where is the non-uniform one? So if we don't have any non-uniform one, then potential difference. Okay, so this, okay, so let me give you guys a non-uniform, right? I don't have it in here, so let me give you a non-uniform. So you have an electric field. Find the work done in bringing a charge of 6 microcoulomb from x equals to 1 to x equals to 5 in the presence of the electric field, which is how much? 3x square I hat, right? So this is the electric field. And we want to find out volt per meter. So this is the electric field and we want to find out what is the work. So this would be how much? What kind of electric field is this? So electric field is 3x square I hat. So this is variable, right? This is variable. So work done from initial to final point, this would be minus Q initial to final point E dot dr. This would be the electric, this would be the work done. And what is this dr? So this is the displacement. So we are moving in x direction only. So then dr would be simply dxi hat. Right. If we are moving in x and y direction both, then this is for one dimension. If we are moving in two dimension, so dr would be dxi hat plus dyj hat. And for 3D, this would be dr would be dxi, dyj, and dzk. So these are the different forms of dr, but we are only moving in x direction. So this would be n. So let us put this value, and this work done would be how much? So work done is minus Q is 6 microcoulomb, right? And then from x equals to 1 to 2, E dot dr. So E is 3x square I hat dot dr, which is dxi. So how much is this thing? So this is minus 6 into 10 to the power minus 6. 3 is outside. And then this is 1 to 2. Oh, this is 5. So x is going to 5. And this is x squared dx. Right. Is it clear, guys? Okay, so this would be how much? This is 6 3s are 18 into 10 to the power minus 6 x square integral. How much is the x square integral? What is the integration of x square? Yes, guys, what is the integration of
2x.
x? We are calculating integration, not differentiation. Integration. xn dx
X cubed by 3.
Yes, so this is xn plus 1 n plus 1. So this is correct. Yes, absolutely correct. So this is x cubed by 3. And then limit is 5 to 1. Right, so how much is this thing? So you have minus 18. This 3 is taken outside. And 10 to the power minus 6. 5 cube minus 1 cube. So this is minus 6 into 10 to the power minus 6, 125 minus 1. So this is minus 6 into 124 into 10 to the power minus 6. So how much is that? 6 4s are 24, 6 2s are 12 to 14, 6 1s are 6 and 7. And then 10 to the power minus 6 joules. So we can write this as minus 7.44 into 10 to the power minus 4 joules. So this is the answer, right? Is it clear? So this is the work done in the presence of variable electric field. So non-uniform electric field. So this is how we calculate the work done. Quickly note this thing down, and then we will understand the idea of work done and potential. What is the work done? But before that, we'll talk about yeah. So we'll talk about the electric potential. Yes, whenever you guys have noted it down, please tell me. Yes, whenever you have whenever you guys have noted, please tell me.
Yes, sir.
Done. Okay, so now because we have understood the idea of work done. So now we can talk about what is electric potential, right? What is electric potential and what is potential difference? So can you guys tell me what is electric potential and what is potential difference? Can you guys tell me the difference between these two? Yes. What is the difference between these two? Okay, so let me just recap or just remind you guys that electric potential, this is just denoted by V, and this is simply the work done in bringing a charge from infinity to a fixed point, and we are bringing a unit charge. So that is what we call the electric potential. And what is the potential difference? So potential difference is we are bringing a unit charge from a fixed point to another fixed point, right? So that is the potential difference. Okay, so this should be delta V, and this is written as V final minus V initial. So this is potential difference. Is this part clear, guys? Is this part clear? Is it
Yes, sir.
clear? Yeah. So then we already know that how do we define this work done. So we defined this work done. This was minus Q E dot dr and initial to final. So this is how we define this thing. So let us use this thing and let us write the electric potential. So using this idea, electric potential would be W infinity P divided by Q. So this is minus Q integration from infinity to P point, and then E dot dr divided by Q. So this Q cancels, and we have infinity to P and E dot dr. So this is electric potential, right? And then we have the potential difference, which is how much? This is IF by Q. So I will directly write that this would be initial to final and E dot dr. So this is the potential difference. This is electric potential. This is potential difference. So we are talking about from infinity to P point, and this is from A to B, from two fixed points. That would be the potential difference. Is it clear, guys? Okay, so if it is clear, if you guys don't have any question, so now let us understand. Now let us understand that what would be this potential difference for the two forms of the electric field. So potential difference, this would be again two types. This is dependent upon E. So this is uniform. This is what? So this is variable. So this would be how much? V final minus A part for uniform. For uniform, this is V initial and minus E dot R final minus R initial. So that is the potential difference for uniform electric field. And for variable, that we already know. So for variable, potential difference is minus initial to final E dot dr. So this is the potential difference, right? And you guys have already learned that there is a very important relation that can be derived from here. Right, so from here we can define a very important relation that work done. So work done, let's say from A to B, in bringing a charge from A to B, this would be Q VB minus VA. So this is how, this is a very important relation. Right, so we have talked about electric potential, we have talked about potential difference, we have talked about the relation between work done and potential difference. Right, so any doubt up to this point? Any doubt up to this point, guys? Okay, so if you guys don't have any doubt, then let me talk about, and these are the results that you guys have already seen. So this is electric potential. Electric potential of different species, right? Or different combination of charges. So first is for a single charge. Can you guys tell me what is the electric potential for a single charge? What is the electric potential? Yes, this you guys have already. What is the electric potential of a single charge? Due to a point charge. What is the electric potential due to a point charge? So you have a charge Q and you are trying to find out the electric potential at this P point at some distance R. So what is Vp? What is this Vp? Do you guys remember? Okay, so this is simply KQ by R. Right? So this is for a single charge. And what is the electric potential for multiple charges? For multiple charges, the total potential is sum of the individual potential, right? So this is the electric potential. And then you have the third point, which is for a dipole. So let's say you have a dipole and this is minus Q, this is plus Q, and you are trying to calculate at this P point, which is making an angle theta, right? So then what is the potential at this point? So what is Vp? So do you guys remember what is this potential at this P point? Yes, do you guys remember that? Okay, so this is Kp cos theta by r square. So this is the potential of a dipole, electric potential of a dipole at this point P. Here this small p. So this is small p is the dipole moment, right? So this is the dipole moment. And this is all we know, that this is charge into separation, right? So these are the things that we have to remember. And if you guys can tell me that what is, so can you guys tell me that what would be the potential at axial point? What would be V axial? What would be V equatorial? Using this thing, can you guys tell me what would be V axial? What would be V equatorial? So for V axial, what is theta? For V axial at this point, what is theta? This is the axial point, right? And this would be equatorial point. So what is theta in here? What is theta in here? Can you guys tell me what is theta in here? Yeah, this is simple, right? This is the angle theta, and if I'm at this point, so what is my theta? And if I'm at this point, so what is my theta? Yes, guys, tell me. So, oh, why this is not erasing this thing? Again, this. Okay, so something weird is happening to this thing. Let me just. Okay, so let me just share this thing again. Okay, so now we are, yeah, and let's hope that this is now working. Okay, so what was this thing? Yeah, so now it is working. So theta would be 0 degree for axial point. So V axial, this would be simply Kp by r square. And for equatorial, theta is 90 degree. So V equatorial, this would be 0. So electric potential is 0 at equatorial point. Electric potential is Kp by r square at the axial point. And if we compare it with the electric field, elect electric field was 2 Kp by r cube. And for equatorial, this was minus Kp by r cube. So we see that the electric potential, this is varying like r square. Electric field is varying like r cube. So this is what happens for the case of dipole. For dipole, right, for dipole, we have this thing, and this is the potential, and this is the electric. So this is the electric field of different charge system. So for single charge, this is kq by r, kq by r. For multiple charges, we have to just sum it up. For dipole, this is kp cos theta by r square. And now we have this important thing. So this is for conducting solid sphere, or we have on non-conducting non-conducting hollow sphere, or we have a conducting hollow sphere. So for all these kind of spheres, what would be the, so for all these kind of spheres, what would be the distribution of charges? So all the charges would be residing in here at the surface, right? So for this kind of distribution, the potential, for this potential, there are three conditions, right? So one is that you have inside, and then you have surface, and then you have outside. So there are three regions. So potential would be inside, that is, let's say the charge is Q. So this is KQ by R. And then you have V surface. Okay, so this is capital R. Right. Let's say this is the radius distance. V surface, that is also KQ by R, and V outside, this is KQ by the distance from the center of the sphere. And if you plot the graph of this thing, so the plot of this thing would be, let's say this is R equal to R, and then R is moving. This is the potential. So at R equal to R, this would be constant. So at this point, this is constant, and then it is decreasing as this thing. So up to this point, V is KQ by R, and then at this point, it is inversely proportional to R. So this is the thing, right? Just note down this part, and if you guys have any confusion, please tell me. Just note down this part, because these things you guys already know, right? So these things you guys already know. So just note down this part. Quickly note this thing down, and then we will do the question. So now we have understood that how many potentials we can calculate, and then you guys just, yeah, whenever you guys have completed noting it down, please tell me. Oh, who got disconnected? Freedom got disconnected. Okay, Alia, whenever you have noted this thing down, please tell me. Yes, Alia, noted.
Yes, sir.
Okay, so now what have we studied so far? We have done that what is the work done for the external electric field, and we have studied that depending upon the electric field, there can be two kinds of work done. So one would be due to uniform electric field, the other one would be due to the variable electric field. And then after studying about the work done, then we talked about that what is the electric potential. Electric potential was related with the work done, and it was the work done in bringing a charge from infinity point to a fixed point. So that was the work done, that was the electric potential. And then we talked about potential difference. So potential difference was work done in bringing a charge from point A to point B. And then we also saw that depending upon the kinds of electric field, we will have different kinds of electric potential or potential difference. And then we talked about the electric potential of different distributions, right? So these are the things that we have done. And there is also one important thing, and that is the relation between. So let me write this thing. And that is relation between potential or electric potential and electric field. So this is called the electric potential, or this is called the electric field as the gradient of potential. So let's say you are given potential. Then from that potential, how you can calculate the electric field? So electric field is defined as minus dV by dr, right? So this is how you calculate the electric field. So you can calculate, let's say that this electric field will have three components. This is the vector quantity, right? So if you want to calculate x component, so this would be minus dV by dx. If you want to calculate y component, that would be minus dV by dr. If you want to calculate z component, that would be minus dV by dz. So these are the electric fields component, and the final electric field would be how much? That would be EXI plus EYJ and EZQ. So if you are given a potential, right? So if you are given a potential, then you can calculate the corresponding electric field. So please note down this thing. This is also very important. Please quickly note this thing down. And what I will do is that I will also talk about the other concepts so that our conceptual part is completed, right? And then we will do all those questions. Yeah, whenever you have noted, please tell me.
Done, sir.
Done. Okay, so let us do some questions and then we'll talk about the next of the topic. So the next of the topic is potential energy and then capacitance. So these are the two other topics that we have. So, but before that, let us done some questions, right? So let us do some questions. Yeah, what is the potential difference here? So this one we can do. And this one is quite easy to solve, right? So we have this question. So we have this question. And what is the potential difference in bringing a charge from A to B in the presence of this electric field? Right. So the question is that we want to calculate potential difference VB minus VA. This is what we are trying to find. Right. And we know that this is how much? So this is a uniform electric field. Right. E is uniform. So E is uniform, so potential difference is how much? This is simply minus E dot RB minus RB. So that is the potential difference, right? That we have just studied. So this would be how much? Minus E, that is 2I plus 4J plus 3K, and dot RB is how much? RB is I plus 2J plus 3K minus RA is how much? 2I plus 3J plus 4K. And then if we solve this thing, so how much is this? Dot I minus 2I, that is minus I. And then 2J minus 3J, that is minus J. 3K minus 4K, that is minus K. So then we have how much? I minus 1 we can take, and minus minus would be positive. So that would be 2 into I, that is 2, plus 4 into 1, and then 3 into 1. So that is how much? 3. So this is 9 and volts. So this is the potential difference. Is it clear? Yes, is it clear?
Yes, sir.
Okay, then please quickly note this thing down, and then I will ask you the next question. And then, yeah, we'll move on to the next topic. Yeah, whenever you have noted, please tell me. Yeah, noted, Ali.
Yes, sir. Done.
Okay, so now you please try this question, right? So this question is, so this one is due to the variable one, right? So this one is, okay, who got disconnected? Learnivio got disconnected. So please do try this question. This one is a variable one, right? And remember, in this one, we have three integrals, right? So okay, so yeah, what we can do is that we can do this question together. Yeah, let me just. Yeah, so let us do this question together, right? So we have electric field which is variable. So E is variable, right? What is that? This is 2 by x cube I hat. And then we have what is the potential difference in carrying a charge from A to this in the presence of this thing, right? So let us calculate that. And we know that this is only electric field is only in the x direction. So dr would be simply dxi because other parts are zero, right? So potential difference is how much? That is minus E dot dr, and from I1, which is because you see that this is only x. There are three quantities x, y, and z. But because electric field is only in x direction, so you will have x1 and x2 only. Right, so this is how much? This is x1 is 1 and x2 is 2. And this is 2 by x cube I hat dot dxi. So this is 1 to 2, and this 2 is taken outside, and 1 by x cube dx. So what is this thing? So this is minus 2. This is x to the power minus 3. So the integration would be x minus 3 plus 1 minus 3 plus 1. Limit is 2 to 1. So we have minus 2. Minus 2 and minus 2 will cancel. And this is x minus 2 and 2 to 1. This part is cancelled. So we have 1 by x square from 2 to 1. So how much is this thing? So this is 1 by 2 square minus 1 by 1 square. So 1 by 4 minus 1. So this is minus 3 by 4 units. So this would be the answer. Right? Is it clear? If it is clear, then quickly note this thing down. Yeah, please note this thing down. Whenever you have noted, please tell. Yes, whenever you have noted it down, please tell.
Done, sir.
Done. Okay, so now let us do some questions on electric potential. So, due to one charge, we already know. So now let us calculate from different charges, right? So this thing we have already understood. Now let us understood about or okay. So this is okay. So now let us do another question. So yeah, these are the kinds of questions that we. So okay. But before we do this, do we have any multiple charge questions? No, but yeah. So let us do this question. Okay, so these are the kinds of question that we have, and we want to calculate. We want to calculate what is the potential at A and what is the potential at B. So that is the question. We have how many? Three hollow spheres. So three hollow spheres we have. We have three hollow spheres, and we want to calculate the potential at A, and we want to calculate potential at B. So this is the question, right? And then we can calculate what would be the work done in bringing some charge from A to B, that we can calculate. But before we do that, let us find out what would be VA. So this is these are all the hollow spheres, right? And we know that what is, so we already know for a hollow sphere, we know that what is the electric potential. So electric potential inside for a hollow sphere, that is kq by the radius and v surface. This is how much, that is kq by radius and then v outside, this is kq by distance. So these are the potentials for a hollow sphere, right? And I want to calculate who joined and who got disconnected. Okay, so who joined and then got disconnected. Okay, so we want to find out potential at a point. So how many contribution would be there? If I want to calculate potential at A. So how many contribution would be there? Yes. Please tell me how many contribution would be there. I want to calculate V at A, potential at A. So how many contribution would be there? Yes, Alia. So there would be three contributions because there are three charges, so there would be three contributions. Right. One would be due to this Q1 sphere. The other would be due to Q sphere, and the other would be due to Q3 sphere. Is it clear? Yeah, let me sit properly. So, is it clear to you? Yes, is it clear to you?
Yes, sir.
So there are three contributions. I'm calculating the potential at this point. So one contribution is coming from this sphere, smaller sphere. The other contribution due to this sphere, the other contribution due to the biggest sphere. Now, if I'm calculating this A point, so due to the smaller sphere, this A point is inside, surface, or outside. What is that? Because these are the three potentials for different cases. So for a smaller sphere, for this sphere, right, for this sphere, this point is outside or inside or what? For this sphere, this A point is inside, at the surface, or outside. What is that? Yes. Did you understand my question? Because we know that for a sphere, there are three potential. So depending upon where we are calculating the potential, we can have three different potential. If we are inside, if I'm calculating the potential inside, then this would be kq by the radius of the sphere. Again, at the surface, that is same, but at outside, we have to calculate the separation. So due to this smaller one, this A point is outside. So this is outside scenario. V2, due to this sphere, Q2, this A point is on the surface. And then due to the third point, so due to this Q3, that is inside. Right, so what would be V1? V1 is outside, so that would be KQ1. And what is the distance from here to here? What is this distance? What is this distance? So we have to calculate the distance, right? For our outside, we have to write the distance. That is B. Now, due to this surface thing, so that would be simply Q2 by radius. What is the radius of this sphere? The radius is B, right? So this would be B. And then due to this third sphere, which is inside. So for inside, we write the radius. So that would be KQ3. And what is the radius of the third sphere? What is the radius of the third sphere? Yes, what is the radius of the third sphere? That is C, right? So this would be K by B is common. This is Q1 plus Q2 and then KQ3 by C. So that is the potential at. Is it clear to you? Is it clear? Okay, so now let us find out the potential due to B. But before we do that, oh, what is happening? So, yeah. Okay, so this is 90. Yeah, so let me, what happened to this thing? Okay, I have to cut this thing and then start it. So let me. Yeah, let me start this thing again. Okay, so let me share this thing again. Yeah, so this is what we are calculating. Right, so you just note down this part and then we will talk about. So then we'll talk about the other things, right? So then we'll calculate what is the potential at B. So first you note down the potential at A. Right, just note this part. And if you have any doubt, please tell. So just note down up to this point and then we'll calculate the potential at B. Quickly note this thing down. Whenever you have completed noting it down, please tell me. Yes, whenever you have noted, please tell me. Okay, so who has joined? Who is Vivek? Yeah, so do you note down this part? Yes, Anu. Whenever you have noted it down, please tell me.
Done, sir.
Yeah. Okay, so now let us calculate the potential. Let me just bring this thing here first. So now let us calculate the potential at B. So now we are calculating the potential at B. And remember, the potential due to a hollow sphere will have three conditions, right? If we are inside at the surface of the sphere or outside the surface of the sphere. So we want to calculate potential at B. Again, it will have three contributions of three spheres. So from three spheres, it will have three contributions. One would be due to this smaller sphere and then the middle and then third sphere. So this smaller one is this point, right? This B point is outside, inside, or at the surface of this smaller sphere. What is that? So that is outside. Again, due to this second sphere, due to this second sphere, This point B is again outside. So that is again outside. And then this 3 point at this third sphere. The third sphere, this B point is at the surface. Right, so this is surface. So if we write all the potentials, so what would be that? So this would be KQ1 and the distance which is C. Again, this thing which is Q2, again the distance which is C. And then this is the radius which is C. So this would be K by C and Q1 plus Q2 plus Q. So that would be the potential at Is it clear? If it is clear, then quickly note this thing down. Please note it down. Yeah. Whenever you have completed noting it down, please tell me. Yes, whenever you have noted it down, please tell me. Yes, noted.
Yes, sir.
Okay, so then we have this part is completed, right? And yeah, so this would be all. And then we have talked about the electric field as gradient of potential, right? So you will have some question like this one, right? So potential is given, and then they are saying that calculate electric field. So you have only X part, so this would be EX only. And then you just calculate the electric field. So E is this thing, and then you calculate the electric field. So all these questions we'll talk about in the next class, right? So we have potential energy and capacitor. That is the only thing that is remaining. And then in the next class, I will also start. This electric current. I will quickly finish these two topics, and I will start electric current.